വാക്കിൻ്റെ ശീലു ചൊല്ലുവാൻ നാവിലാകേണമേ. സ്നേഹമാകുന്ന ഗീതമോ എൻ്റെ കാതിലിണയാകണേ. സത്യമെന്നുള്ള ശീലമോടെന്നെ ശാന്തിയറിയണമേ. ഭൂമി അമ്മയെന്നറിയുവാനുള്ള ബോധമുണ്ടാക്കണേ. ജീവജാലങ്ങളാകെയും ജന്മബന്ധുവായിടണേ. ജാതിഭേദങ്ങളെന്ന ശാപമോ ദൂരെ മറയണമേ. ലോകമൊന്നെന്ന പാഠമെന്നുമെൻ മനസ്സിലെഴുതേണമേ.
Thank you, sir. Now, I would like to invite my friend, Cadet Bablu Shrikar, to continue with this session. Bablu,
Thank you.
over.
Thank you, Asya. In order not to disturb the course of the guest talk, I request all the attendees to mute their mic except the speaker. Now, I would like to welcome our campus director, Dr. C. Suryanarayanan, for the welcome address. Sir, please.
I have already welcomed our guest, and I again sincerely express my gratitude for Dr. Boris Lisika, and thank him again, and a warm welcome for our guest speaker today. We all get immense benefit from his talk, and it's a great experience for us. At the same time, I also welcome all other participants and the seafarers who are invited for this talk. Thanks a lot, Dr. Boris Lisika, and it's a great privilege for us to have you here with us. Thank you. My video, I think there is some difficulty. I am sorry for that. I hope I will join. My video will be on in a few minutes afterwards. Thank you. Please carry on.
Thank you, sir, for those kind words. Now, I invite our HOD, Captain Vinod Naveen, sir, to introduce our respected speaker. Sir, please.
Yes, thank you, Bablu. Confirm I'm audible, clear?
Yes, sir, you're audible.
Yeah, just a reminder, I see that our Google Meet capacity is full. So I hope we are running this on YouTube. Is our YouTube started, Bablu?
Yes, sir, we are set.
Yeah, just check on that because we have got 100 full capacity on this Google Meet. Yes, so good morning to Captain Boris. Thank you to Captain Dev Goswami, respected director of IMU Kochi campus. Let me just take, before I introduce, let me just take back a few steps just to, for the benefit of the speaker, that we at IMU Kochi, we started this guest webinars in February of 2020 as a part of our knowledge series. The basic aim of our knowledge series was to bring experienced, expert, eminent personalities from our industry who can share their experience and expertise to the young cadets. And we are very fortunate that from the time we started this webinar knowledge series from February of 2020 to now, it's almost coming to 2 years. We are very fortunate that we have got really eminent personalities who came and spoke on variety of topics over the last 2 years. And I think we are yet again fortunate to have an expert and experienced speaker in the form of Captain Boris today, who will be speaking to us on gas tankers. To the students, as I mentioned, this is part of our knowledge series. There are speakers like Captain Boris who comes and shares their experience and expertise, and the basic purpose of this knowledge series is for you to broaden and enhance your knowledge. So I hope you will give your full attention to the words that is going to be spoken by our eminent speaker today. And just one question to all the audience: how many specialist doctors will you find in a hospital? Right? You know, in a hospital, we have lots of doctors, medical assistants, and so on. But when it comes to specialist doctors, there will probably be only one or two. And in some hospitals, no specialist doctors at all. So the topic that you're going to listen to today is a very special topic. It cannot be spoken by anybody and everybody, not by me, because I've never sailed on a gas tanker. So it's a specialist topic. That is why we have a specialist come today from Croatia. It's our first international speaker coming to IMU Kochi. So we are very grateful to, first I would say, to Captain Deb Goswami, who arranged Captain Boris Lisica for this meeting. So thank you, our gratitude to Captain Deb. And then our special thanks to Captain Boris, because you are our specialist today. What you are going to speak is probably what this crowd has never heard. So it would be really enhancing their knowledge on gas tankers. I wouldn't be the right person to introduce the speaker today. So let me leave that honor to Captain Deb Goswami to introduce the speaker. But let me introduce Captain Deb Goswami before he introduces the speaker. To introduce Captain Deb, I think I don't need to talk about him. I'm just going to read out the degrees that he have or the qualification that he has. He has an MBA from shipping and logistics from London, and then he has an MPhil, a DBA from Netherlands, and then he is also a fellow of the CM Company of Master Mariners Mumbai branch. He is a member of the Nautical Institute London, and more importantly, he is one of them from our own fraternity. He is a captain who has sailed for about 40 years at sea. So I don't think I need to give any more introduction to Captain Deb Goswami. His qualifications speak for himself. Let me not waste any time, and let me request Captain Dr. Deb Goswami to introduce our guest, Captain Boris Lisica, today. Over to you, sir.
Yeah, thank you, Captain Vinod. Thank you for the nice words you put across. It means a lot to me. Just one question, Madam Vice Chancellor, Dr. Malini Shankar, is here with us today?
No, sir. I checked with Madam in the afternoon. Because of her engagement, she is not able to make it, but she has conveyed her best wishes to you and to the speaker.
Thank you, Captain. Anyway, since I was expecting her to be here in the flyer, I saw it. So let me start with her because we want to give her the highest honor. So let me start. Respected Madam Chair, Vice Chancellor Dr. Malini Shankar, IAS, Dr. Surya Narayana, Director, Indian Maritime University, Kochi campus, the convener, Captain Binod and Captain Rakesh, the team of Nautical faculties, Head of the Department of Management section and his faculties, and of course the students who will be our future leaders in shipping tomorrow. Good afternoon. IMU has been characterized by its initiatives to be bold and set a new direction by inviting eminent speakers from shipping to give insightful speeches to encourage its students. Today, our speakers, Captain Boris Lisica, first known as the retired captain of a gas tanker ship, as one of the top 10 captains in TK shipping ever had, who influenced and encouraged many young officers and crew members to climb up on the career. During his time, he was one of the most influential people in TK LNG's business. He joined TK Shipping in the year 1987, and then he moved to Gas Tankers Division in the year 2005, and has command experience of 32 years, which is the longest serving master in TK Shipping. Captain Boris is a person of many talents. He is a shipping professional, a philanthropist, and an earth lover. His donation to help needy families in Croatia goes more than 50,000 rupees annually, and he produces enough vegetables to support himself and to the people in his neighborhood. Students, I think what you can achieve to him, and by following his guidance, it will have an immense value in your career. I'm pleased to present Captain Boris Lisica from Croatia.
Thank you, Dave. Thank you for nice words. Well, what I want to say is I'm first seaman, and don't expect so much fancy words like Dave is using, but I will try to my best. For a presentation today, I have been asked to show one video. This is my company that I retired from, and I will share a short video and then we will go with presentation. Is that okay with you?
Yes, Aditya, it's fine. We can start with the speaker now.
Yes, sir. You can start.
Yes, Captain Boris, please go ahead.
Okay. That is the video coming up. I hope it is coming up. There it is.
You need to give the sound, Boris. You need to give the sound.
I have a sound. I can hear the sound. I don't know if you can hear it or not, but I can hear the sound. I'll try again. Because sound is at maximum, so it should be working.
No, we cannot hear the sound.
Cannot hear the sound of the video. Okay. And then anyway, video is another 10 seconds, so it's not really much that it says. It's only pictures. What I wanted to go on about this one is just see the pictures of the shipping. Anyway,
Captain Rakesh, I think two of them might have to drop out. Otherwise, Captain Boris might find it difficult to come back. The number is full.
Yes, sir. Yes.
Just always keep it just 1, 2 less so that he can come back in. Yeah, okay. I think now, no.
Yeah, please log in. Boris, please log in. Log in. Ah, okay. Now we can.
Yeah,
thank you.
Yeah. You can unmute, Captain Boris. You can unmute.
sorry about that. I was For some reason, it got disconnected and I got back and it took time to reconnect.
No problem. You're on.
So anyway, I will start the presentation right now, and then we can go from there. So this is the first slide that we are going to go through. Before we go through it, you can look at the picture and read what it says. I'd like to say a few words. I would like to say that my expertise is LNG. The lecture is about working aboard gas tankers, but it will be about LNG carriers. I don't want to encroach on the LPG, LEC tankers, because that will not be truthful or 100% certain what I'm presenting. First and foremost, LNG carriers are all about safety. It is built into the vessel, first at the yard, with safety culture cultivated and enforced. And failing to follow safety practices is a big career damaging issue. Apart from risking own and other lives, it doesn't pay not to follow and apply safety practices. What needs to be emphasized is that anything connected to LNG is all at once complex and complicated, with a lot of science in that we, at least deck officers, were never trained about. Now we go through first slide, and you can see the full cycle of the business as it goes through. Most of the projects around the world have been made as a full circle project. Namely, production and transport are all the part of the same project, meaning that the vessels are also part of the project. Frequently, buyers make part also. These are very expensive exercises. Just one example or two. Wheatstone project in Australia, which is a rather small project, total cost was $30 billion without ships. Gorgon project, also in Australia, it's a little bit bigger, and it cost $54 billion. Jamal project in Russia, in the region north of the polar circle, with the temperatures going to -50 and everything, and it's a pretty big project. That one cost 27 billion without ships. What you have to also look at is that one LNG vessel, it costs around 200 million. Floating storage and regasification unit is around 300 million, and Yamal icebreakers are also each 300 million. So this is big money we are talking about, very expensive, and the industry as such has always wanted to stay safe, and that's why the ships and everything else is so expensive, because big part of the cost is safety. Then another perspective is spot market charter rates. Just this year, they were ranging from $30,000 a day to $260,000 a day. These are enormous rates, and it tell you the tales of volatility of the market. I would also, before we go on the second, I will actually change the screen so you can look at a little bit better pictures than what is the one before. I would also like to say how much shipping is part of the total cost of the LNG production and sales and everything. Shipping actually takes 20% of the total cost, so it's a very big cost, shipping. Liquefaction is the biggest cost, around 40%, and shipping 20%, this is over 60% just in these two. And production is the cheapest, actually not only production, but exploration and production is the cheapest at 18%. So it is rather complex and expensive business. On this picture, or this slide that you see now, you can see what it says on the screen. Platforms which are pumping gas into the trains. You see the trains, the train is a very expensive and very big thing, and it looks like a train and has several thousand kilometers of small piping inside that serve for liquefaction. And so it is, anyway, something that we are not meeting every day. The third picture down on the screen shows the storage facilities of one LNG terminal, a jetty, and the ship loading. And the last one is, of course, in this picture, 2 ships carrying cargo to destination. Here on this slide, we can see some of the features of a discharge side of it. This was deliberately picked up Japan and Sakai, and LNG carrier of the Moss type with spherical tanks. And you can see here the storage tanks, and from storage tanks the gases or liquid is pumped or regassed and pumped into the gas grid of the city, country, or whatever it is that the grid is made for, straight down to consumers. You can also see an LNG tank, shore tank, which are very big structures, and original ones, when all this business started, rather small, and they were usually sunk into the ground. Today they are all above ground on special foundations, and they are getting bigger and bigger every day because technology and everything is catching up with all this, and it's getting bigger. So now they are to the tune of 200 to 250,000 cubic meters each. When you stand underneath one, it's enormous, it's huge. And that's just to put perspective onto some of the things that are happening in this industry. We have to go, in order to get into the gas or LNG, we have to go a little bit into the science. And these are the natural gas properties on this screen. They show what is the most common natural gas made of. There are always a little additional ingredients, but mostly it is methane, ethane, propane, butane, a very small amount of pentane, very small amount of nitrogen, and this is just about this. These are also the features of the gas, and one of them is molecular weight. I'm not going to go into it, but this is an important factor when you are doing the calculations. Boiling point is also very important, because boiling point is usually stated and at a temperature and atmospheric pressure. And most of the cargoes are actually liquefied cargoes are carrying at their boiling point, which means at atmospheric or very near atmospheric pressure. And then it gives you densities here, but we are not going to dwell on that because this will make it too complex and too much bogged into it, so to say. But you can find any of that if you are interested further to study the gas. You can find it anywhere on internet or in the publication specialized for it. Anyway, so this slide is about same gas properties, sort of, and it's also about one society that plays a big role in the gas industry, which is a SICTO, and as you can see here, Society of International Gas Tankers and Terminal Operators. And the publication where you can find just about everything about gas is Liquefied Gas Handling Principles on Ships and in Terminals. Latest edition is 4, and you can peruse it to find a bit more. Although I would say if you're going to go there, you have to study a little bit more beforehand because some of the things will not be easily understandable. At least they weren't to me when I was cadet learning the LNG business. Boiling point is what I said before, and molecular weight is their explanation and why it is important. And the most important actually feature that the IGC code defines the gas from is saturated vapor pressure. And you can see there that liquefied gases are liquids with a vapor pressure exceeding 2.8 bar at a temperature of 37.8. That saturated vapor pressure follows the gas throughout and operations and everything else. Although nobody is using it as such, but it actually is always in the background doing this or that or whatever else it is doing, but it is there. And the next slide is the today most widely used LNG carriers. The top one is Moss-Rosenberg type or spherical type, and below is a standard outline of the membrane vessel. There are a few other makers of this is based on containment system, meaning that the tanks where the gas is kept. So on the Moss type is kept in these spherical tanks, and on the membrane tanks is kept in the tanks surrounded by the membrane. And this just gives you a picture how that looks. Now we will touch here the LNG ships boom. At least when I started at sea, this was something that was just heard about. This is how one can say it. It was an isolated niche, and same as entire industry up to the 70s. And then it slowly started picking up. And from 70s, by 2000, there were about 130 LNG ships in the world. And most of them were Moss, but the membrane started picking up in the 90s. And, there were a few ships, maybe 30 on the membrane ships by 2000, maybe a bit more thereabouts. And then in the 2000, the boom started in a big way, an unbelievable rate. I don't know if you have heard, but Qatar was until sort of yesterday the biggest consumer, the biggest producer of the gas in the entire world. They produce annually 77 million tons of LNG. Australia has overtaken them just last year or year before last, but it's still very, very big. And that's the early 2000s when Qatar came online and ships associated with Qatar gas. And then by 2003, there were already 153 ships, and then in 2004, 176. And at that time, most started going on the new building decline because of the size. At the time, they could not go over 135,000 cubic meters capacity, but the membrane size vessels went up to 150 by early 2000s, and then they slowly kept on increasing. And then you can see by this screen how many ships were actually going very quickly, how the building was going. By the end of 2010, there were already 360 LNG carriers. Q-Flexes came, this is Qatar gas ships, and Q-Maxes came with 266, the biggest, 1,000 cubic meters. By mid-2010s, standard size from those 150 and 135,000 went to 170, 180,000 cubic meters. That trend is there up to this day. By the end of the last year, there were 642 LNG ships in the world. And then maybe 30 more we will deliver this year. There are just membrane, 180 new buildings on order as of September 2021 for deliveries up to end of 2024. Then Japan has come back with building ships, and they are rapidly renewing their aging Moss fleet, because Moss fleet is now coming 30, 40 years of age. It's time they retire. Moss vessels are being built effectively in Japan only. Although there are other shipyards, but Japanese buyers tend to go Japan for new building unless they are forced elsewhere. The membrane has become the containment system of choice, with various variations of the standard systems. NO96 Mark III, we will talk about that a little bit more later. SPP is also coming back. These are prismatic tanks, very much or almost the same as oil tanker cargo tanks, only they are made of aluminium and they are cryogenic. Together with Moss, they are supposed to be the best tanks on the market because they have no restrictions and no restrictions of any kind, and much simpler to work and everything else. But they are also the most expensive. That's the reason why they are not on the market. However, SBP tanks are being fitted as a fuel oil tanks on container ships, cruise carriers, and everything because this is probably the best choice. And they are also fitted into floating production and storage vessels of the LNG as the forwardmost and aftmost tank because these are usually the worst as far as sloshing and partial loads go and so on. And just 2-3 years ago, there were 4 new ships being built in SPB system. These are also by Japanese owners. They will be carrying cargo from Cove Point in USA to Japan, built exactly for that purpose. What you have to understand is that unlike most of the other ships, LNG ships are being built for a service life of 30 years, which means service life of probably 40 years. And judging what is being seen around, they can do that without any problem. Anyway, we go to the next slide, which shows actually what is available of the containment system for LNG carriers today. As you can see, this is IHI means Ishi Kawaima Harima Heavy Industries of Japan. They invented this SBP in the late 80s, and the first 2 ships ever built on this were 1993 for Alaska trade, and these ships are still in service today. And you can see aluminum alloy thickness is 30 millimeters, and insulation is polyurethane foam 270 millimeters. Moss type is also aluminum alloy, same as SPP, but the thickness of the tank is 50 millimeters. And then you come to the membranes. GTT NO96 is Invar. Invar is 36% nickel alloy. And GTT Mark III is stainless steel, 1.2 millimeters thickness of the primary membrane. What I would like to say while we are on this screen, that we need to mention IMO IGC code. IGC stands International Gas Carrier Code. It is a lengthy name, full name of this convention that is in force, and the latest one has been in 2016. The one before that was in 1993, and most of the day ships were built on that code. However, there were quite a number of improvements as the industry grew up, so that did technology. And all these new improvements and new insights were built into in 2016 IGC code. And this is the governing publication. It's the law for the gas tankers. And the name of that publication is International Code for the Construction and Equipment of Ships Carrying Liquefied Gases in Bulk. No wonder somebody shortened it out to International Gas Carrier IGC Code. It sounds much better. And here we are on SBP in IHI type of the vessel. You see, these 2 ships on the first slide. They look like ordinary tanker. You don't see anything different. They have a little compressor house in the back end in front of the accommodation. Look like ordinary tanker. Today, the new buildings, in order to make capacity, they have raised the deck up to the trunk deck and raised the tanks up. Otherwise, it was not possible to build bigger tanks. So they look a lot more like membrane vessels, the new ones, the 4 new ones that came just 2 years back. And this here picture shows the tank from inside. Tank is, in essence, complete crude oil tanker tank. because it has all the girders, all the swash bulkheads, center bulkhead, everything is there, which makes it for a very safe tank and reduces vaporization of the liquid and everything. And that's why they are the safest, and that's why they are the most expensive, I guess. And this tank is being just carried by the huge, you can guess, a crane to be fitted into the hull of these new tankers that have been built just a few years back. And that slide here shows how it looks underneath the tank. This is support and insulation. Insulation, if you remember, is polyurethane foam. We go to the next one. These are all what we are doing now. We are looking at building types of the LNG carriers. And here you can see what it is there for the Moss type. So this is the tank, how it looks like. It's the old tank. The new tanks are a little bit more elongated in this middle section. They call them apple, like apple tanks. They elongated the equator, and the top sphere stayed the same as the bottom sphere, but the middle was elongated to increase the capacity, because that was one of the issues with Moss type. They couldn't go further than certain capacity, because that will make the ships too big. This way they have managed to keep the ships of Panama size, which means being less than 49 meters, this new Panama Canal, not the old one. And that way they have, came back into the business, because at 135,000 they couldn't compete anymore. This here slide shows you, this is the tank, and this is the skirt. The equatorial ring in the middle, skirt is something that the tank is sitting on, and in the hull. Otherwise, it will be going all over the place. And it is supporting the full weight of it and make it by IMO prismatic type B tank. That's what makes it in that sense. This is a special alloy here, and probably cost more than entire the rest of the tank, this equatorial ring, but the design requested, there's no choice, they had to do it. And this is how the tanks go into the ship, as you can see here on this ship, and a tank being fitted in. And on the bottom is some explanation about Moss type tank, and you can see the cut view of it. And on the right-hand side is the latest model of Moss type called Sayendo. It is a Japanese word that means peace, like a pea in the pond, if you know what I mean. And this blue structure on top covers all the tanks, and as opposite to what used to be, each tank used to be covered by itself, and it was just a cover containing insulation. But now this cover, like this, makes the ship more streamlined, and also this is a part of the ship structure, strengthening quite a bit the hull. Because if you look at the picture above, you see these many holes, so the strength of the hull is somewhat compromised. With this new structure on top, the hull becomes much stronger, and that was the idea. A lot of improvements in the Moss technology coming. We will say a few words about that one later. The next slide is showing a membrane, and this is generic view of the tank, how it is made. Here in the back is called a pump tower, and this here is actual cut drawing of or a sketch of the Mark III membrane tank, indicating all insulations and things like this. And here below, this ship is Mark III. The difference between is right here, Mark III NO96. You see the front end of the trunk deck is sort of square. And here is narrowing down to the front. This is because of the construction issues with NO96 as opposed to Mark III. They have to narrow down the forward end. This picture actually shows the ice-breaking Arc 7, classified Arc 7. This is for working in effectively North Pole or South Pole. These are icebreaker LNG carriers. We have been mentioning them before. I will show a picture later on how does it look when it's breaking ice. Let's go to the next slide. That will give you some ideas, the differences between Mark III and NO96. I have already mentioned most of it, but what I would like to say is that the company that is behind these two is one company. Actually, there were two companies in the early 90s that merged eventually into one company. First one was Gas Transport. That company invented NO96. And then Technigas company invented Mark III. These two companies merged into a company called GTT, which is a short word, Gas Transport and Technigas. They just collected the names together. When they just merged, they put on the market membrane type CS1. That one was not very long lived. Only 3 ships were built on it, but it was interesting combination. It was a combination of Mark III and NO96, where the primary barrier was Invar and secondary barrier was triplex. The triplex is epoxy, sort of composite cloth, sort of. But that one, I think, didn't fare very well, and they stopped production and carried on improving each of these membranes. They have made considerable improvements in insulation and just about everything else. Invar, which is a 36% steel, stands for invariable. Invariable because it remains unchanged, shrinkage or expansion wise. Meaning when it is exposed to cryogenic temperatures, it does not shrink, and when the temperature comes up, it does not expand. That's what 36% nickel does. What I would like to say also, there is a lot of expressions here in these presentations. They are going to be strictly gas. They are not heard around a lot, and one of them is abbreviation MARVS. Of course, on the ship, you always short that to the simplest, so it's MARVS. It means maximum allowable relief valve setting of the cargo tank. This is safety valves on each cargo tanks. And on all of these ships, each tank always has 2 safety valves. And they are piped. You can see on those ships, they have a very big masts, vent masts, and all these safety valves are piped straight into the vent mast. Because if they release, there is going to be a lot of gas, and you don't want that gas anywhere low and near you. The pressures they are set on LNGs are 25 kPa. I don't know how familiar you are with kPa as against bar or some other measurements, but 25 kPa is a quarter of a bar. So these are very low pressure and speak back towards what I said before about cargo carrying at near atmospheric pressure at the boiling point. This is just a little bit raised pressure in order to stay at sort of atmospheric. Today, more and more ships are being built, or LNG ships. That was quite common for LPG tankers, but LNG has only recently started putting a little bit more pressure in the tanks. So these safety valves have either low setting when you come into port and carriage setting for sea. Carriage setting for sea is usually 70 kPa, and this is actually maximum allowed pressure that IGC code permits for gas carriers or LNG gas carriers. And they are going over there because keeping the higher pressure helps with the other things, particularly in carriage. And here, when we are on it, I would like also to give some operational insights. The tanks are separated by cofferdams. These are quite big, quite wide, or longitudinally wide, and tall all the way to the end of the tank, all the way to the trunk deck. And this, because on each side, at least the middle tanks, there is cryogenic cargo, there will be obviously seepage of the cold into the cofferdams, and the cofferdams are built with carbon steel for cold weather, sort of cold carbon steel, maybe not the right expression. And these carbon steel for cold, maximum temperature it can take is minus 50 centigrade. And it is expected that with two tanks close by, that the temperature in cofferdam is quite likely going to reach that temperature. There is a problem with that because the carbon steel, when it gets cold, it gets prone to brittle fracture. In effect, I'm not sure if you are aware of the brittle fracture, but this is if you, which is available everywhere, if you take, say, liquid nitrogen, a little bit, throw it on the steel, let it disappear, and everything still looks perfectly all right until you top it with something and it just goes into dust. And you can imagine the consequences of the ship hull going into dust, so nobody wants that to happen. And these cofferdams are heated. And not only heated, there is two systems, separate systems that heat the cofferdams. So if one fails, the other one is always there. On the other thought, the LNG ships are all about that kind of redundancy. Everything is double. There is no way any critical equipment is not going to be there without backup. And that goes for everything else, not only that. Now we go to one very pretty picture. This is actually a picture of the tank of the ship, which was delivered. This was done on delivery of the vessel I was on. As you can see, it was done by professional camera. This is Mark III membrane, and the tank is about 45,000 cubic meters. When you come into that tank, it's an enormous cavern. When you come down through that pump tower in the back, which is over 30 meters tall, and when you look down into that hole, if you are suffering from vertigo, it's not a good feeling. And so it's enormous cavern, but spectacular, as you can see, to look. The primary membrane is, as you can see, it is corrugated stainless steel. Of recently, they have, because corrugation acts as bellows, as expansion joints to help with, because stainless steel is not inward, so stainless steel contracts considerably, and there has to be some expansion bellows to do that, to allow it to do that. And of recently, GTT has improved on corrugations even further. So these ones here, if you see the pointer, these ones here are now also corrugated. The longitudinal ones, not yet, but these ones, these are special machine corrugated. These ones, and each piece of membrane comes in 3 meters by 1 meter pieces. So the press that does this have to be of equal size, and obviously stainless steel that comes in is a lot bigger before it becomes 3 by 1 meter by the press. We already had said that secondary membrane is composite material, and insulation is reinforced polyurethane foam. On the Mark III, I would like also to say that as the industry changed as regards propulsion and lesser BOG consumption, we will go to these BOG, BOR and everything later, Mark III followed that progress as regards boil-off reduction over the years. Standard BOR used to be 0.15% of the total cargo per day. And by 2017, it has gone down to 0.07%. So this is a massive improvement, mostly done by thickness of insulation, but nevertheless is a massive improvement. The secondary insulation place, the one attached to the hull, because it has to be attached to the hull, on both membranes, has a bilge well with level alarms and pumps connected. This is for the purpose of detecting any leakage from the ballast tank or any condensation. God forbid any condensation in the insulation places, or even more so any liquid, because at minus 165 it will freeze and then it will deform insulation, deform membranes, and that means catastrophic damage to the ship. So this is why this is very carefully looked into. There are alarms, there are pumps, and there is a drop of water in it, immediately gets pumped out, and it's checked regularly. Now we will go to the picture of NO96 tank. And then you can see there is no corrugations there. There are just, you see these strips on the bottom, because Invar is made, during tank construction, is made into U. It comes as a roll of metal and then goes to a special machine that makes a shallow U. And that shallow U is then inserted into the insulation. And in the middle of these two U's, there is a strip that is actually holding the membrane in place. And then all these three units are welded by a robot. That robot is a fascinating machine and, to watch and everything. And it travels a full length, all of the 45 meters of the tank or something. It travels along until it comes from one end to another. The corners, the robot cannot do. And the corners are done by highly qualified and experienced welders. And these welds are very carefully checked by experts before they are allowed to be okayed for use. Interesting fact about Invar is that despite 30% nickel content, it will still corrode if introduced even to just humid air. So throughout construction, humidity in the tank is kept very low with dry air constantly pumped in. Dry air during the shipyard time, dew point must be at least minus 20. So there is no humidity inside at all. Also because dirt on your shoes or oil from the bare skin can also influence corrosion. If you touch by a bare finger, it leaves a greasy mark on the membrane and it will corrode over there. Although Invar is coated with some sort of like a grease, but it's not grease, it's like some oil, very fine coating, it's still, your finger is capable of removing that oil and leaving a mark on the membrane. So you always have special shoes, covers, and cotton gloves. You don't go into the tank without cotton gloves. On both of the membranes, the critical part is also that you must not carry any loose objects on you when you're entering the tank. It has to be tied up on you, or you leave it at the tank top. There is a guard on the tank top ensuring you don't bring anything into the tank. Because you drop something, this is only 0.7 of a millimeter membrane Invar, and you make a hole, you have made one very expensive repair, and that's why this is just not happening. And from the other aspect of the operational side is when the ship leaves the yard on the first cargo and several cargoes after, the ship's crew has to carry ballast tank inspections, checking for cold spots. The cold spots are just accumulation of ice, you can see it from miles away. And these are indicating that membrane is not doing as it is supposed to do, or there is a small leakage. Because leakage is possible, it only vaporizes so quickly. This is what they call microscopic or nanoscopic holes. in the membrane. They are possible and they are accepted fact, but what happens in there, it evaporates very quickly in such a small amount that purging of the barrier spaces by nitrogen, which is continuous, 365 days a year, 24 hours a day, it's permanently purged, and gas detection is in there. So any gas leaking into barrier spaces is immediately detected and you knew something is wrong. But the cold spots are, very efficient and very simple inspection, and the shipcraft is doing it. And Mark III also has produced evolution towards the reduction of boil-off rate, and in the moment has gone from 0.15% to down to 0.1%. And NO96 is at near 0.015%, was primary boxes were 230 millimeters, secondary boxes were 300 millimeters, filled with perlite. In order to improve and reduce boil-off rate, they have changed that to glass wool and polyurethane foam, and that's how they have actually succeeded to do that. Now, the next slide goes to propulsion developments. Why I am going on to this is because it's important. It also drives the industry towards membrane improvement and also insulation improvement, and also have changed the original concept of LNG carrier. LNG carrier originally was any kind of a carrier, moss or membrane or anything, was steam turbine, single prop vessel, usually with the bow thruster. That first changed with Qatar Gas building of Q-flexes and Q-maxes. And the original vessel was always burning boil-off gas into the boilers and producing steam out of it and propulsion for it. Now Q-flexes and Q-maxes come by and they don't burn anything. They have fitted a liquefaction plant on the ship and fitted two traditional main engines, each on one propeller, running on heavy fuel oil. And this was a big, big change in the concept and everything. However, that didn't prove, most likely, I hear on the grapevine that they are trying to think of converting these engines and diesel generators to burning gas, because HFO is, plus being more expensive now than gas, was also a problem with NOx and SOx reductions that IMO is pushing, and they will never be able to achieve that on heavy fuel oil, even on the low sulfur heavy fuel oil. So that's going to be, like in a tanker industry, this is going to be a big problem for these ships. However, now the conversion cost is to the tune about $20 million. So I'm not sure that Qatar Gas is going to invest into it. Maybe they'll rather scrap the ships than go that way, but it remains to be seen. They are only 13, 14 years old. There is still 20 years at least to go in their lifetime. The next type of the vessel is DFDE. These are dual fuel diesel electric. This is medium speed diesels running actually marine gas oil. Marine gas oil is car diesel, exactly that. These diesel engines, they provide electricity. They run on gas all the time, as long as you're allowed to burn gas. And they provide power for two electric motors going through a single propeller through reduction gear. Then next evolution was obviously marine gas oil was expensive. The next invention was three-fuel diesel electric. They added heavy fuel oil to it. And then these ships were, still kind of, in comparison, same with, despite different propulsion and many things better, but they were still on the same rank as a steam turbine classics. The only thing was they improved other things, but they were on the same rank in that sense, except they were a little bit bigger. They came to 150,000, 155,000 by 2010 capacity. The next big invention was Meggy, because we call these ships Meggy, because these MAN BMW, they invented the slow speed two-stroke diesel engines to burn gas. They fit two sets of the engines with twin propellers. The difference obviously is 300 bar gas injection into the engines, which means you have to have a high pressure compressor on board, which is as big as a house, or if not bigger. And it's one very mean machine. And these engines are running on a classical diesel cycle. Power production on these ships is also put on gas, but not at 300 bar. This is a low pressure, also MAN produced diesel generators. The next invention of XDF. Producer is WinGD. This is a Swiss company which was ex-Sulzer. If who have a long memory ever heard about Sulzer engines. Wärtsilä, which is a more familiar name today, at one time bought Sulzer, and they have now separated, or Wärtsilä sold their share in WinGD to Chinese interests. They came also with low-speed diesels, also two engines, direct coupled to two propellers, but injection pressure is low, 10 to 12 bar gas injection, and it is autocycle. If you remember what autocycle is, it's a gasoline engine. Autocycle is when you mix up the air and the combustion material, petrol in this case, and then spark plugs ignite it, which they do here the same, only no spark plugs. And then they have also power generation diesel generators, which are most commonly Wärtsilä, last I heard, on low pressure gas. Wärtsilä is using 5 bar injection into diesel generators. The latest one is pure Japanese invention, and first invention was ultra steam turbine. Ultra stands for ultra efficient, because turbine is known for a poor thermal efficiency, and they have improved efficiency of the turbine considerably, and that's why it's called ultra steam turbine. It was one generation of ship that was built only on these UST system, and then of lately they came with this stage, which is UST plus DFD. So you have a steam turbine driving one propeller and electric motor driven by generators on the other shaft, which is a very interesting, very interesting detail for how the shipping is being going, in which direction they want to have facilities of both for some reason. Anyway, now I think we are finished with highly technical details. We'll look a little bit at better pictures. And this is a picture straight out from the shipyard. And this is a keel being laid. What was traditionally keel being laid is a very small piece of steel. Now the pieces are coming in gigantic bits and pieces like this one. And this is for the LNG carrier, and you can see the scaffolding there. Scaffolding comes onto the keel blocks right away erected so that they can produce they can carry on with the membrane construction as soon as the ship is closed. And you can see how big is this section. When you are nearby one and hanging up in the air, it's enormous. And this is part which was there in the air is coming on the blocks, and you can see here, here is one tank, this is a cofferdam, and this is another tank. Well, it's not a tank, it's just a keel. And then comes the complete ballast tank on the side and the upper deck, and then comes a trunk deck on top, and comes a bow and the stern, and then the ship is launched. Once the ship is launched, the construction of the barrier starts. And Next slide is more technical, and it shows a pump tower. This makes for a picture which is interesting to see, and to the eye who does not know, it looks also very strange. But the pump tower is over 30 meters tall and three-legged, three legs. And this here is a cargo pump. One on the other side is another one, and here you have filling line on the right slide or slide picture, and in the middle is a pump tower base, because a pump tower obviously cannot be attached to the membrane, and it cannot be attached also to the ship's hull, because it will pass through the membrane. Who is going to make this not leaking? So not possible. So this pump base tower is in a special way connected to the hull, and then the tower is sliding up and down for shrinkage and expansion. This pump tower shrinks 8 centimeters from the ambient to the minus 162. So it has to travel up and down on that slide. But also you have to prevent a cold temperature going to the hull. And then, except spray nozzles, which we'll come to that later, everything else that is in the tank is fitted onto the tower. Absolutely everything. And then every bolt and nut is tuck welded. So there is nothing ever going to come loose, because it will damage either the pump or tank itself. And this is every single bolt and nut during the building is verified being welded, and nothing is left to chance there. Cargo pumps are three-stage centrifugal, running on electric power. The voltage on these ships was in the early days 3,300 volts. Nowadays is 6,600 volts. This is a very high voltage, and there is obvious reasons why that was done, to reduce amperage and to reduce the cabling diameter. Here we come to another strictly LNG, showing you liquid dome and vapor dome. Liquid dome is an extension of the pump tower out on deck and connected into the pipelines. I have put a name to each of these, what they are, but I don't think it's worthwhile going what they are one by one. If anybody has any questions after, we can discuss. What I would like to show, these two here, if you can see the pointer, are safety valves. And on the other slide is a vapor dome. Vapor dome is in the middle of the tank, exactly in the middle of the tank, and only vapor is coming out through it. Although on NO96, spray nozzles are also fitted into the vapor dome. But this is neither here, neither there. The most important part is somewhere that you can vent the vapor, and somewhere you can load or discharge the liquid. Now, you remember I said something about BOG and BOR. There will be a little comparison. BOG stands for boil-off gas, and BOR stands for boil-off rate. Boil-off rate, I will use the old one at 0.15, and most standard size today, 175,000 cubic meters cargo capacity, equals to 262.5 cubic meters of boil-off gas per day. Vessel have to use this gas responsibly, meaning no waste, no venting. So it has to be used either in propulsion or in power generation, or both, or liquefied, or mixture of all, or any of these three together. And there are, trust me, mixtures of everything. And this is just for comparison further down. Older steam turbine vessels were using 355 cubic meters per day. DFD E 270, MEGI 227, XDF 222. So the new ships, that's why I was mentioning this requirement to reduce BOR. They have to reduce to 0.1 or below Otherwise, they wouldn't be able to deal with extra BOR. They have to burn it somewhere, and that means GCU, which is a total waste. GCU is gas combustion unit. The other info was I wanted to say was TCP, time charter party speed for most LNG carriers is 19.5 knots, and they always have a 20% margin built into it. And also, which I already mentioned, BOR 0.15 was standard until 2010. And here are some pictures. You see, it says underneath each picture, you can see the stainless steel manifolds. And on the left-hand side, this is loading at Gorgon terminal. This is built specifically. That picture you never forget. Once you're there, you right away know it's Gorgon by the construction of the jetty. And here on the right-hand side, you can see the loading arms completely frosted. This is because the cryogenic temperature or cold temperature collects the humidity from the air and it deposits on arms and whatever is exposed on the ship. Because most of the lines on the ship are insulated, but the exposed parts are always completely frosted, sometimes very thick. In high humidity, very thick ice on these arms and pipes. And this one we will not go through very long. It just shows, the CCR abbreviation usually stands from cargo control room. Officially is called cargo compression room for using same abbreviation. So we either use colloquially either compressor house or compressor room and not CCR, but this is how it is abbreviated. CMR means motor room. Well, this is another part of technical aspect of the building. And you see on the bottom right says airlock. If the entry into motor room is on the cargo deck or on the trunk deck, it has to be airlock. So if you open both of the doors simultaneously, everything trips. You can trust me that the chief engineer and chief mate are going to eat you alive if you do that by accident. So you have to close one door before you open the other one. And that is the purpose of the interlock, not allowing any gas to enter. And also these two rooms have bulkhead in between, has gas seals and everything, so nothing goes either way. And the arrangements of all these rooms can be wildly different. In a sense, depends on what kind of ship you are on. This one here is per D&D ship, but it could be any kind of equipment inside compressor room, including complete reliquefaction plant, which are inside. And you remember we were talking about heating the cofferdams. Here are the two heaters and the pumps, associated pumps, they are right here for glycol system. And on the old ships, these motors here were steam turbines, and now they are gigantic electric motors driven by 6.6 kilowatts. Now we go into cargo operations, starting from dry dock or a new building back to dry dock. They are listed down in the order of the sequence they come. And we have already mentioned tank inspection. Then before you go anywhere else, you inert insulation spaces with nitrogen. Nitrogen is produced on board, and there must be no oxygen inside at all. And then you inert cargo tanks and pipelines. I will go briefly through all of this. I'll go just back a little bit to inerting. Each membrane has its own pressures and everything else associated with the insulation spaces separately. So this is depending on the type of the ship you adjust accordingly. So, and then we go to inerting cargo tanks and pipelines. Inerting is a multi-purpose operation, which reduces dew point of the tank atmosphere to low -40 degrees to avoid any possible condensation anywhere in the system. Condensation in cryogenic temperature creates hydrates, which is similar to CO2 white powder, which can block all sorts of things, and you don't want there, so the dew point must be very low. And then also you are removing oxygen out of the system, so that when you introduce gas, you don't create any explosion range, flammable range. The oxygen is reduced below 2% there. This, the inerting cargo tanks, it takes about 20 hours, all going well. If you keep a piston effect working properly, it takes 20 hours to the minute. But if dilution happens because, for whatever reasons, we don't go into it, it's too technical, then if it happens that you have to have a dilution, then you have a problem, it takes a lot more hours. Anyway, you go now to gassing up the vessel, because what you have to do is you cannot have CO2, which is 15% component of inner gas. You cannot have it inside, as CO2 will freeze at -60 degrees. And if it freezes at -60 degrees, whoever has seen CO2 fire extinguisher, it's a white dust. And exactly the same will happen in the cargo tank. And this is again problematic for filters, pumps, and all sorts of things. And you don't want that to happen. So when you're gassing up, you have to displace all of the inner gas and CO2, and you cannot gas up the vessel with a temperature colder than -20. So you stay above -60. And then it's cooling down the tanks and cargo lines, because the stress to everything coming from an atmospheric temperature or ambient temperature to -162 is huge. So cooling down is another process that you do to the tanks and to the lines before you actually introduce liquid into it. The cooling down, I will just mention, is limited. The rate of cooling down is limited to avoid excessive stress to the tower. And then also, if you cool down too much, you will overrun capacity of HD compressors pumping the gas ashore. And then also the interbarrier spaces cool down too rapidly, and nitrogen cannot keep up with it. Anyway, we will go, this is not to go too technical. In any case, just cooling down the tanks. Tanks are cold when average tank temperature reaches -130 degrees centigrade, and then you can start loading after cooling down the lines as well. This is another aspect of the technical aspect of the business. It's a powered emergency release coupling. As you can see on the picture there, it is powered. It means when the signal is generated, it just splits the arm into two, and the section of the arm just flies back ashore. This was designed, main reason for design was the arms moving outside of the envelope. The position of the ship is, during the operation, strictly checked and recorded on the hourly basis, and any movement is immediately taken care of by attending to ropes and all sorts of things. But you can never take out of action ship passing by and pushing the ship on the ropes in any direction. And when the system comes out of the envelope, emergency shutdown is activated, and then immediately arms are decoupled. The good part about it is it's very close coupling, so there is a very small amount of liquid which spills down onto drip tray. Drip tray is stainless steel, so there is no damage. The only thing is when the crew hears all the alarms going, crew moves away very quickly. This is part of the training. Now we go to loading cargo. I'm not going to dwell on this one too much. This actually here shows exact sequence of the events as they happen. If we start reading to it, this is going to be too complicated. But I would like to say something about one feature that is strictly LNG trade is pre-operations meeting with the terminal. This is a very serious business and very serious meeting. Every single detail is discussed. Plan of action of any kind of action is discussed, and papers are signed, and before the meeting nothing else happens. So one has to come prepared to it, and of course knowing your ship and your data, and provide everything they ask. And another part of it is also inspection by the berthmaster. We also, even sometimes before connecting loading arms, there is inspection by the loading master who goes all around the ships and checks everything and then says, okay, let's go. Now, the next slide is a little bit more down to earth, shows, like I said, I'm not going to go into operations in detail. We already went too deeply to it. This is the first slide is engine control room. Everything happens right there in that control room. Starting anything, including engines, propulsion, absolutely everything happens over there. You know, prudent mariners, they always are on the site when something is being fired up. And this is also part of the deal. And these, on the right-hand side, the second deck is here on one of the ships, showing how comfortable design is. And you can see working on this one is it's far away from crawling into some holes and coming out covered in oil and everything. This is very convenient. The bottom left shows DFDE engines. On the left, as we look at it, is V12 engine, and on the right is inline 9. Left engine is about 15 megawatts, and right engine is 11 megawatts, if I remember correctly. On the right-hand side is a steam turbine. If you have never seen a steam turbine, it looks like two small boxes, especially when you look from the top of the engine and you can barely see, and you're wondering what is that there. This is actually steam turbine. And this one here has about 40,000 horsepower. So, but it's small. I will interrupt some of these more technical bits with sightseeing pictures. We are now on laden sea passage, which is complicated in itself, but the main purpose is to limit the tank pressure and keep as low consumption as possible of the gas. But this is not always so simple. It's frequently contradictory to each other. But part of the business, no point going over there. But the picture over there shows ice-breaking LNG carrier going stern first, which is the position when the biggest thickness of ice is possible to break. This one here can break about 2.5 meters of ice going astern. I think only 1.5 meters going ahead. So the same applies for loading cargo, discharge cargo as well. We will not go into each item, but same as here, meeting and inspection. What I would like to say is most of the production terminals are very far from anything, and over there nothing can come to you, but the discharging terminals are sometimes very close, like Boston is in the middle of the city. But security is very high, exceptionally high. There is no way anyone can casually walk into the terminal, and even less so to turn up at the vessel. The vessel always receives visitor list long before berthing, which includes even the ship's crew joining and anyone else that will board. Nevertheless, ship has to follow ISPS requirements to tiniest detail and verify each person against the list and ID. They are not allowed on the ship if they don't have ID. ISPS is same all over the world, and And the ones who are not allowed to come to the ship, they will not even try, knowing where they are on LNG ships. So, anyway, we go to the next slide. And this is the outline of the cargo pipelines when you look from the top. And if you have been on, or if you have seen the cargo pipelines of some other ships, these ones have nothing in common at all with any of that. No point going through it. Although the right bottom picture shows expansion joint. This is stainless steel expansion joint covered in ice. You see it has the restriction bolts to not allow it to go either in either direction too much. And these expansion joints are allowed only on vapor lines. Liquid lines are U-bent. And then we go on to ballast passage. Ballast passage is a heel dictated. How much heel you have on board. Heel is another strictly gas expression. It's a liquid which is left on board after discharging. It is deliberately left for purpose, or if you were stripping out, it was unpumpable. And with that heel, you do all sorts of things, including cooling cargo tanks and preparing the ship for loading and burning it all in propulsion and power generation. On the right-hand side is another tidbit of the LNG specialty, and this is the manifold filter. This is a Mesh 60 filter. It's a two-way filter that goes into the manifold and everything is going through it, in and out. So just to show some parts of it. And we have been talking about hazards, and these are more how you call it, human hazards, although flammability is not only human, but and mitigation that the ship has inbuilt or is doing on its own on LNG carrier. First and foremost, ship is built with safety in mind, sort of, and everything, the systems are designed around safety. So the methane in gaseous form is in flammable range between 5 and 17% in air. All the ship systems are closed circuit, so there is no gas leakage of any kind. Stringent safety and operational procedures and design to remove ignition sources and oxygen in areas where possibility exists. Not to speak about gas detection just about everywhere, and at 60% LDL, ESD is activated if it is detected in critical places. Fire detection, I don't know how many hundreds of detectors are of all sorts. Fire, heat, gas, everything. This is a funny part, is that we call a gas chamber. It's a smoking room. On gas tankers, there is only one smoking on the ship, built on purpose, for purpose, and it has a huge air exchange ratio in the safe way. And there is no smoking elsewhere, neither in the cabin, nor on the bridge, nor in the engine room, not in the bilges, nowhere. Cryogenic temperatures. It's a frostbite and brittle fracture. You can imagine if there is a drop of minus 162 LNG dropping on your skin, what is the effect? It's immediately burned right through, worse than fire. So there is a PPE, personal protective equipment, being worn. Training is continuous on the ship, absolutely all the time, to make sure nobody forgets anything. And then from cryogenic part, every single flange or possible leak source has a stainless steel drip tray underneath for obviously drips. Anything more than a drip, this will overflow, but hopefully we will be able to catch it before it happens. Water spray system is instantly available. Another thing of the gas carrier is underneath the manifold, there is a rail through which runs the water continuously over the ship's hull. If there is any leakage that will overflow drip ray on the top, that will run straight down on the ship's hull, and that is why that water curtain runs all the time there. And if you look at the gas carriers, you will see a rusty streak midship. That is what that seawater running causes it. Asphyxia, obviously, every gas is asphyxiant because there is no oxygen in it. So normal procedures standard procedures applied to that. Toxicity is limited on LNG. Some LPG components are there, but have it, but not really to that extent. Pressure is another issue. You have to watch out pipes and tanks and watch out for surge or trapping liquid. For that, you have measuring device relief valves and valve interlocks not permitting trapping liquid. Then you have incidents with cargo transfer, dock moorings, and everything else. So now we will just go quickly through at least some of the pictures without going any further because I have been too technical. And you see this is safety features. We will go quickly through. And this is some shipbuilding pictures. And this is mega ship installation of the engine. We will bring this to the end in a minute. Just let me go through the slides so you can see some. This is STS operation, and this is a backwater spray in action. This is gas combustion unit, very big machine. This is the bridge, and you can see standard configuration, except that you have also integrated automation system consoles that are operational from the bridge. And here are some just for fun pictures. If you have a free fall lifeboat, you launch it in a free fall. And then you have to do, in any case, we have to do that mandatory by SOLAS. Maneuverable exercise, this one shown here in the picture is full, just it wasn't a human, it was dummy thrown into the sea and recovered. And this is something I am sure you're not going to be seeing very much. This is a star site, as it is properly done. With EGDIS today, I don't think anybody will be doing that. And this is thing that you should not be doing ever on a gas tanker. It shows gas cloud enveloping the vessel. This is a SIGTO training picture and closely investigated. And this is below 100 cubes spill. Very small, and you can see the cloud, how far it has gone and how dense it is. And there it is. I leave some pictures there to look at. And if there is any questions, let's go. Thank you. I hope I was not too technical, although it is very difficult from my perspective, being very close to the business, to extract something that will be understandable and provide a picture of entire business, because as you can see, there is a lot to it and it's not that simple.
Yeah.
Yes, sir.
This is like this is like masters in LNGs.
Sorry about that.
No.
Captain Boris has actually covered a semester syllabus in 1.5 hours, I should say. It's a full syllabus of gas tankers, but I should say, just allow me, Bablu, for a minute. I should say you took us right from the history as you were showing the chronological order of development of gas tankers and gas tanks. I think you actually stripped the gas tankers for us. I mean, it was beautiful to see those stainless steel tanks that you were showing, the inside pictures, probably something that we have never seen. So you stripped it for us. You took us through the different type of tanks and wonderful pictures. I mean, it gave us a good insight into what really is a gas tanker. I would say, I mean, you even showed us some future developments, very interesting figures for cadets. I would say you said there are 30 yard deliveries in 2021-22, which is about 2.5 gas tankers every month. And with 640 gas tankers already, it's a market that is coming up. I'm sure these cadets will be sailing on one of those gas tankers in the future, and they will definitely remember Captain Boris for this lecture. Thank you.
I hope these young men who are going to be able to see something in it, because when you board the ship, LNG tanker, it seems like you're boarding a space shuttle, and it's not immediate because the gangways are always the same, and you're climbing up, struggling to get on top. Once you come on board, it looks ha 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 ha. But once you come inside, and a couple of days later, you realize how much of it is inside. You then say, wow, what is this? And this is what I was trying to say. It is very difficult for me to move from technical stuff and make it easy for these young men. But I wanted also to show that specifically for me, I spent 25 years on oil tankers. When I came to gas tanker, it was completely new world, but completely. There is, except traveling through the sea, there is nothing similar to it. And this is what I try to convey. And sorry, I don't like you to disappoint you, but this is only maybe 5% of all the reason gas tankers.
So, any question and answer that you can ask?
Yes, sir. Now it's time for the Q&A session, and I would like to hand over the floor to my mate, Cadet Aditya Upadhyay. Aditya, over to you.
Yes, thank you, Bablu. So we have a bunch of questions in the chat box, and our first question is from our HOD of Nautical Science, Captain Vinod Naveen sir. The question is, are there any difference in safety between SPB, MOSS and membrane type LNG carriers?
No, safety is always utmost. Whatever ship you are on, say it is first. There is no difference. In essence, when you look at the construction, the membranes are more prone to damage, but they have been around very long time and there are actually very few damages. And ships usually get caught in bad weather, and this is where damages happen, but there has not yet been any breaches of the membranes. It's only expensive repair once you come to the shipyard, but no breaches. So this is the only difference if we are talking about safety in that context.
Right, so thank you. Next question we have from Cadet Gaurav Pandey. The question is, among MOSS type, membrane type and SPP tank types, which offers maximum cargo carrying capacity without losing cargo capacity due to its structure?
Membrane. Membrane is the smallest of all the ships in comparison with the equal cargo carrying capacity.
Right, so next question we have from Cadet Shaurya. The question is, among which of the type of tank carrying cargo is more safe for seafarers and which is more backbreaking for seafarers?
Neither is backbreaking because these ships are very clean and very easy to operate. It's just a lot of science to it, and you have to be familiar with it. But actually, for backbreaking work, there is none as far as the cargo goes. You never see anything, you don't smell anything, you are not exposed to it, nothing happens. But membrane type, the safest cargo containment system will be most in SPP because you don't have any issues with that. Absolutely no issues because the sphere has no free surface effect, no limitation of loading, no sloshing, and same is for SBB tank because there's all these barriers inside and bulkheads and everything, also no sloshing, no free surface, while membrane has a free surface and sloshing issues. However, it has another advantages in carrying capacity, and that's why it is predominant today.
Right, sir. Next, again, we have a question from Captain Vinod Naveen, sir. The question is, what are duties and role of a cadet in LNG cargo operations?
Cadet is off any other duties during cargo operations. He is not 24, but he is on disposal to chief officer throughout cargo operation. Of course, he has to sleep sometimes, so chief mate will pick up the time when he wants him there. During the most critical stages, cadet is there to learn the trade. And during the sea passage, cadet is part-time on the bridge, part-time around with chief mate. Because cadet is going to be a third officer. As a third officer, he is going to have all sorts of responsibility. It be that life-saving equipment, or cargo papers, port papers, or hospital, because today hospital is also an LNG tanker duty of the third mates. Second mate is too busy with other jobs. So this has been dumped on the third mate under auspices of chief officer, hospital. And then he has also firefighting equipment, and you can imagine how much firefighting equipment there is. Plus you have we have to do exercises every week, sort of. And then we use 2-3 air bottles for PA sets. He has to recharge bottles, he has to change filters on compressor. There's all sorts of jobs, and a cadet has to learn all of these jobs, otherwise he's never going to be officer. And that is why part-time is navigation, part-time is out on deck. And anytime there is any cargo-connected work, cadet is called from all the duties, get over here, we are doing something that you need to know.
Right, so. So next,
seems the cadets.
Yes, sir.
Seems the cadets are very important persons on board.
Oh, yes, they are. Yes, they are. And I was always welcoming as many cadets as you can. It's a free labor.
Right, sir. So we have a question from Cadet Monis Pagakar. He says that how often is the Mark III and NO96 membrane type tank inspected?
If you don't have a breakdown of some kind, every 5 years at docking time.
Okay.
Let me go back to the question earlier. Cadet also has to have time for study. And that is least available, trust me on that one. And cadet has to really pick up the time to study. And when he is studying, better study. Because when you come back to school, you're going to be missing all sorts of things.
Right, sir. So we have a question from Hitesh Gupta. He says that, sir, is it possible or can we convert LNG into pure diesel oil while deballasting or during the voyage?
I didn't get the question. Transfer to diesel oil. You mean running the engines on diesel or gas?
Yes, sir. For just running the engines.
This is seamless. If you're running on gas, you just press the button, you're running on diesel. Getting back on gas, it's an involved operation. It takes several minutes to move one engine from diesel to gas because system has to be purged, verification has to be done, and system has to gear up. So going to diesel is instantaneous, seamless, but going to gas, it's a procedure.
Okay, sir. So next question we have from Cadet Bablu Shrikar, and he says that what are the effects of the gas cargo when the vessel is passing through different zones and how these effects are minimized?
There is no effect. The only effect you can have is a bad weather. And gas tankers are very quick, and you are following weather reports, and you don't stay in bad weather. And if you are running into bad weather, you keep it on the bow or slightly on the bow to minimize the movement. Because with the movement, there will be more evaporization, and then will be more gas that you have to deal with. And if you're running flat out, you cannot burn it except in the GCU, which is waste. And that's what you try to avoid.
Okay. Right, sir. Next question we have again from Cadet Gaurav Pandey, and he says that is there any effect of overheating of cofferdam to cargo tanks and cargo inside, that is expansion of gas?
Certainly there is, because heat transfer is there, and that's why cofferdams are kept only at 5 degrees. You don't want to go below 5 degrees because if you go lower, it's very difficult to pick it up, so you keep it at 5. So that's why it is limited, but there is always a heat transfer. So everything has effect, and even cofferdams do.
Right, sir. Next, we have a question from Captain Sujit Kumar Patel, sir. He's asking, is the firefighting arrangement on LNG ships sufficient in the current practice?
more than efficient. You have actually too many of it. And as a cadet, you will be thinking, who installed all these on this ship that I have to look after? Trust me on that. It's just too much.
Right, sir. That's all for the Q&A session. Thank you very much, sir, for answering those questions. I believe that everyone got their doubts clarified. With this, we have come to an end. So I would like to invite Captain Rakesh, sir, for delivering the vote of thanks. Sir, please.
Thank you, Aditya. Can you hear me?
Yes, sir.
Yes. Wonderful. Good afternoon to each and everyone present here. I feel very proud to propose a vote of thanks to great intellectuals of different magnitudes involved in this event. First of all, on behalf of Indian Maritime University Kochi campus, I offer genuine thanks to our speaker of the day, Captain Boris Lisika, who invested his most active energy gracing the event. Much thanks to you, sir, and for being with us today and for motivating the future leaders of maritime industry. And also, as a token of our thankfulness, we would like to present you with an certificate of appreciation. Kindly accept it.
Thank you.
Thank you, sir.
Let's see the certificate. Oh,
Yes.
Wow. Thank you.
Thank you, sir.
Boris. One more certificate on your back, huh?
Well, I am retired. So,
Okay, sir.
but it's still pleasurable. Thank you.
Thank you, sir. An uncommon notice to our respected VC, Dr. Malini V. Shankar IAS, and our campus director, Sri C. Suryanarayan sir, for being the impetus that propelled us to put forth a valiant effort and remain as the mainstays of our. Thank you, sir. Also,
you.
it gives me immense pleasure to propose thanks to Captain Dr. Dev Narayan Goswami sir for your precious presence and also arranging such a vast experience expert from LNG sector as today in spite of your. Thank you, sir. Thank you so much for joining us.
Thank you.
As an event
Thank you,
cannot
thank you.
happen in one day without collective effort, I also want to thank our Deputy Registrar, Mr. Mohammad Shaji sir, and HOD of Nautical Science, Captain Vinod Naveen sir, for the immense support. I might
Thank you.
like to want to stretch out my hand from School of Nautical Science, IIM Kochi campus, for being a part of this program. Last but not least, I may thank each one of the students for their support extended in spite of their classes and other key performance activities. So thank you, students, and thank you very much in light of the fact that without you.
Thank you.
Thank you, sir. Thank you, Captain Boris.
Over to you, Aditya.
Yes, sir. Thank you, sir. So, ladies and gentlemen, it's time to wind up the session. Thank you again, Captain Boris, sir, for being with us today and sharing your valuable inputs to all of us. Sir, anything else you want to add on before we sign off?
Just keep at it as a cadet, because cadet is the best time that you're ever going to have on the ship. Even when you come master, you will remember very fondly your cadet days. I, to this day, remember when I was cadet. All the fun and all the learning and how much I was an empty bottle that got slowly filled up with all sorts of knowledge. So as a cadet, enjoy it. You will remember it.
Right, so I'll keep this in my mind. I would like to also thank Captain Dr. Dev Narayan Goswami, sir. Sir, you want to add on something?
No, just a little bit of, especially to you people only. Remember one thing: each master on a ship at one time in his life was also a cadet. We all pass through the same phase, and more you learn at this stage is going to pay you the dividends at the later. So better to gain as much experience as possible because you are young, your mind is fresh. Anything you learn that remains there forever. And be very sincere, be very attentive to your studies. Remember, out at sea, time management is very, very important. You have to utilize the time very correctly to be somebody in future. And we all hope that one day you become shipping leaders in the shipping industry, and we will feel proud of you, saying that these are the people who attended body's lecture on this date, on 30th November 2021. That's it. Thank you. Thank you.
Right, sir. Definitely, sir. Thank
Thank
you,
you,
sir.
then.
You're welcome.
Now I request everyone to switch on the camera for a group photo. Thank you, everyone. We have captured the photo. Great. So I guess we can wrap up this session, and I hope that everyone has gained a lot of information regarding working on board gas tankers.
I think
Before leaving,
my thanks again to Captain Boris Risika and Dev Narayanan for the great support.
right, sir.
Thank you.
Once
Thank you,
again,
Captain Boris, Captain Dev. Thank you so much.
Okay,
Thanks
bye.
to you.
thank you all.
Bye now.
Bye-bye.
Yeah, please go.
Thank you very much, sir.
Thank you, Captain Rakesh and team. Well organized.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.